Hello, I'm Walt Lipke, the creator of Earned Schedule. You may already know, but for those viewing who don't, the Earned Schedule concept became known in March 2003 with the publication of my article, Schedule is Different, in the College of Performance Management journal, The Measurable News. Since that time, much has happened. The method is being used globally on all sorts of projects, big and small. It is being taught in universities and has been extensively researched. Several books now include Earned Schedule. As well, it is now included in one of the appendices to the PMI practice standard for earned value management, and likewise has been included in the National Defense Industrial Association Predictive Measures Guide. There are many more things I could say about the extensive use and propagation of Earned Schedule. However, I will leave that to your own research and refocus attention to introducing you to the Earned Schedule concept. In this video, you will learn that ES is supplementary to Earned Value Management and is dependent upon it. When the video is finished, assuming you are presently employing EVM, you will be able to apply ES to quantify schedule performance for the purpose of project control. Let us begin. Well, just what is Earned Schedule? As you can read, Earned Schedule is an extension to Earned Value Management. The ES measure is obtained using the Earned Value Management measures of planned value and earned value. This point is very significant. With the use of EVM, ES requires no additional data. ES is supplementary to EVM and provides an alternative to the EVM schedule performance indicators, which have been shown many times over to fail for late performing projects. In contrast, ES provides reliable schedule indicators. These indicators always, and I do mean always, converge to the measure of how the project actually performed. Beyond this discussion, ES provides several capabilities for enhancing the ability to successfully manage schedule performance. Later in the video, these capabilities will be identified and briefly discussed. To this point, we've established that ES has been used for more than 10 years, is derived from EVM, and provides reliable schedule performance information. We're now ready to discuss the concept and learn to calculate the value of Earned Schedule. You now have some idea of what Earned Schedule is, but you may not want to go much further if it is difficult to understand or apply. Therefore, we need to spend some time answering the question, is Earned Schedule difficult? I would say not, but I'm a bit biased. There are some who have difficulty with the idea. Nevertheless, in my opinion, the ES concept is very simple. As shown by the image, the two elements of EVM required for ES are graphed. That is, the performance measurement baseline and earned value. The PMB is the time phase values of PV from project start to conclusion, while the accrued values of EV are plotted at the various status time periods. That is all that is needed, the PMB and the EV accrued, both available from the application of EVM. The idea of ES is to determine when the amount of EV accrued should have been earned. The idea is straightforward, but how is it accomplished? Well, let's see. The PMB is the description from the planning and the schedule of how the project is expected to progress. It relates cost with time. Thus, the point on the PMB where PV equals the EV accrued identifies the time at which the EV should have occurred. The time range of the PMB begins at the value of 0 and concludes at the planned duration, or PD. Thus, the values for ES have a defined range of 0 through PD. Therefore, when a project is behind schedule and has executed past its planned duration, the ES value will necessarily be less than PD and will only equal the planned duration when the project completes. Now let's get more technical. How is Earned Schedule computed? As you can see from the image, the time at which PV equals EV is 5 periods. This can be seen by following the red arrows. The horizontal arrow identifies the point on the PMB where PV equals EV, and the vertical arrow identifies the time associated with that point. The amount of time from project start to the intersection of the time axis by the red arrow is the value for earned schedule, that is, 5 periods. The example is simple and to some degree trivial. Obviously, it does not address how the value for earned schedule is derived when the vertical arrow does not align exactly with a period marker. In nearly every instance of determining project status, the vertical arrow will point to a time between 2 periods. So, how is earned schedule determined for this more general circumstance? Let's look at the diagram. As you can see, 2 PV points are identified, one with the subscript C and the one following with C+1. The PMB is created from the PV values from project start to its conclusion. Thus, PV values for each successive time period are known and available for a common computational method known as linear interpolation. In days from the past, interpolation was very common in the use of tables for trigonometry, logarithms, and thermodynamic properties. However, today, with the prevalent use of personal computers, interpolation is little known. Fundamentally, it is a method of estimating at intermediate points. For a general discussion of interpolation, let's assume that the vertical arrow associated with EV intersects the time axis as depicted. That is, EV is intermediate to PVC and PVC plus 1. Using the 3 values, PVC, PVC plus 1, and EV, the fraction of one period of time can be computed. The formula for the fraction of one period, identified as I, is equal to the difference of EV minus PV subscript C divided by the difference of PVC plus 1 minus PVC, that is, the amount of PV in period C plus 1. Having the value for I, the ES time duration can be computed. Using the diagram, we can be more specific in our example calculation. The period value for the PV subscript C is 4, and for C plus 1 it is 5. Although it should be obvious from the diagram, please note that EV is greater than PV4 and is less than PV5. The interpolation requires EV to be intermediate to PVC and PVC plus 1. For the example, it is now a simple matter to compute the value for earned schedule. ES equals 4 plus the interpolated value I, which represents the time duration between PV4 and EV. Thus, ES is greater than 4, but less than 5 periods. To enhance the understanding of the ES calculation, let's use numbers. The values for PV and EV are shown to be PV4 equals 100, PV5 equals 200, and EV equals 130, an intermediate value. The fraction of period to add, that is the value of I, is computed to be 3/10. Therefore, earned schedule for this set of numbers is determined to be equal to 4.3 periods. Although this numerical exercise is somewhat redundant, hopefully it adds clarity and emphasis on the simplicity of ES. At this point in the video, you should have a good understanding of what earned schedule represents and how it is computed. Nevertheless, it is worthwhile to aggregate and summarize what has been discussed. First, earned schedule is derived from the application of earned value management. ES requires a performance measurement baseline along with the value for the accrued EV. Earned schedule is determined from the time associated with the point on the PMB where PV equals the EV accrued. It is the time duration to the point at which the EV should have been accomplished. The time value is computed using the equation ES equals C plus I. The value of C is the maximum number of successive time periods of the PMB for which the condition EV greater than or equal to PV holds true. And lastly, I is the interpolated value computed from the formula shown. Understanding that the numerical result is always less than 1 because EV is intermediate to PVC and PVC plus 1. What can earned schedule tell us about project performance? Is ES a performance measure? Earned schedule is analogous to earned value. Both are measures of accomplishment. EV is that amount of planned value that has been accomplished. EV accrues with project progress until project completion. And at project completion, EV is equal to the maximum PV, that is, budget at completion. Earned schedule behaves in a similar way, with the exception that it is in the time domain. As EV accrues, earned schedule correspondingly increases. The time associated from the performance measurement baseline for BAC is the project's planned duration. Thus, when the project completes, ES equals the planned duration. Earned value and earned schedule as measures of accomplishment inform us that project progress is being made, but they don't provide information as to how well the project is proceeding in reference to its plan. Knowing only the values of EV and ES, managers cannot assess their project's performance for either cost or schedule. There is no basis for implementing project control actions. Earned value becomes useful to project managers through the application of its indicators, cost variance and cost performance index. Cost variance tells us the difference in planned cost for the accomplishment and the actual cost. The index provides us the efficiency of achieving the EV accrued. With these indicators, project cost control becomes possible. One last point. The EVM cost indicators are reliable. That is, regardless of circumstance, they will always converge to the actual result. The fundamental indicators for earned schedule provide complementary capability for schedule control. The two primary indicators are schedule variance time and schedule performance index time. The appended parenthesis time in T for the ES indicators is to distinguish them from the EVM schedule indicators. Just as the EVM cost indicators make comparisons between accomplishment and actual, the earned schedule indicators use ES and the actual duration or actual time, AT. The ES schedule indicators facilitate project schedule control, and as well, these indicators always converge to the actual project result. If the project completed 3 months late, SVT will equal minus 3 months. If the project took twice the planned duration to complete, SBIT will equal 0.5. With the earned schedule indicators for variance and efficiency, we have a basis for project schedule control. Does ES offer more analysis capabilities? Yes, there are several, and they are listed here. However, let's learn to walk first. Concentrate on calculating and using ES and the fundamental indicators. Become immersed before advancing. When you are confident and ready, the first three capabilities listed, forecasting, prediction, and critical path, are recommended for inclusion into the effort of schedule performance analysis. As you will discover by exploring the ES website, there are papers, presentations, and calculation aids available to you. With regard to the remaining items of the listing, they are considered to be advanced techniques. They will require some reading and study. Just as for the first three capabilities recommended, resources are available on the website. During the discussion of the previous slide, I recommended exploring the Earned Schedule website. There is a considerable amount of freely available materials, including published papers, conference presentations, calculation aids, and more. In general, the materials are freely available for download. It is requested that you honor the copyright of the author. For this introduction to Earned Schedule, I have emphasized understanding the ES measure and its fundamental indicators, SV parenthesis T and SPIT. Reading the first of the two articles shown, Schedule is Different, will provide this foundation. The second article, Further Developments in Earned Schedule, introduces the method of project duration and completion date forecasting. Studying this article will help you to advance and progress in the use of Earned Schedule. If you have earned value project data available, I recommend experimenting with the ES Calculator V1B. It is a simple Excel spreadsheet. The output of the calculator is cumulative and periodic values for ES, SVT, and SPIT. And this calculator is easily modified to include forecasting. For your information, there are commercial tools which incorporate ES analysis. A few include some of the advanced capabilities. Although use of a tool provides advantages, my recommendation is to become familiar with the ES spreadsheet. By having this experience, you will better understand what the commercial product claims to offer. A reasonably comprehensive source of information is the Earned Schedule book. The book covers the ES schedule performance analysis capabilities, with the exception of those recently created. The exceptions are advances in schedule adherence analysis, rework forecasting, analysis of discontinuous performance, and longest path forecasting. Also absent is the recent testing of ES forecasting reliability. Of course, the papers on these topics are freely available for download. The Earned Schedule book is available in various languages: English, Japanese, and Portuguese. The English language version can be obtained in paperback or electronic representations, EPUB, Kindle, and PDF. The Japanese book is only available as a paperback. The Portuguese version, titled Prazo Agregado, is available in Kindle format only. Information for purchasing these books is available on the ES website. This concludes the introduction to Earned Schedule. I truly hope the presentation has helped your understanding of the concept, its methods, and capabilities for schedule performance analysis. If you are presently using Earned Value Management, inclusion of Earned Schedule is a fairly simple matter. You already have the necessary data. ES provides project managers with analysis capabilities, greatly enhancing their ability to control schedule performance. I encourage you to give Earned Schedule a try. Thank you for watching.